Imagine looking up tomorrow morning and watching a massive, luminous arch suddenly materialize in the sky from horizon to horizon. It would be the most stunning sight in human history, a permanent, glowing crown framing our planet day and night. Right now, as we see in this full disk view, Earth sits alone in its orbit. We have a clear window into deep space right above our oceans and clouds. But treating rings like beautiful cosmic wallpaper ignores their physical reality. Rings are massive, moving structures with severe consequences for the planet below them. To see what we would be dealing with, look at this full view of Saturn. Its rings stretch out for hundreds of thousands of miles, taking up more space than the rocky body of the planet itself. Zooming in on these dense concentric bands reveals that they are not solid sheets of light. They are made of billions of tons of high-speed debris, specifically chunks of ice, rock, and dust, all locked in immediate orbit. Injecting that much physical mass into Earth's orbit introduces a chaotic variable. This volume of rock and ice forces every other element of the planet's atmosphere and orbital mechanics to react to its presence. This 3D model highlights the most immediate problem. Incoming solar rays hit the dense ring system before they ever reach our atmosphere. The rocks and ice act as a physical barrier to the sun. As the Earth rotates, these massive structures cast thick, black shadows straight across the planet's surface. Because Earth tilts on its axis, these shadow bands wouldn't stay still. Throughout the year, they migrate away from the equator, pushing deep into the northern and southern hemispheres. Any region trapped underneath one of these shadow bands is plunged into an artificial winter. Temperate zones experience sudden, drastic temperature drops, killing off plant life and freezing local ecosystems. Cutting off sunlight for weeks at a time creates severe seasonal shifts, destabilizing global climate patterns and making reliable agriculture nearly impossible. On the ground, the initial human reaction would be pure awe. Astronomers would spend every day monitoring the sky, charting the shifting alignments, and studying the composition of the rocks. Entire global tourism industries would spring up overnight. Millions of people would travel to specific latitudes just to photograph the arc of the rings cutting across the horizon. Humanity would pour money and culture into celebrating the exact same geographical feature that was simultaneously starving their crops and freezing their cities. The danger extends to low Earth orbit. Look at this satellite and astronauts suspended above the planet. This is where our critical technological infrastructure lives. At orbital velocities, every chunk of ice and rock in that ring system becomes a projectile traveling at thousands of miles per hour. This high-speed debris field would constantly threaten and shred the satellites we rely on for GPS, vital international communications, and daily weather tracking. Space agencies would have to invent incredibly complex navigational systems just to thread spacecraft through the gaps in the rocks without being pulverized. These rings create a high-density barrier of projectiles that effectively isolates Earth from the rest of the solar system, making further exploration nearly impossible. A ringed Earth presents a massive contradiction. It offers a breathtaking visual spectacle while triggering a geographical disaster. We want the beautiful sky, but we would be paying for it with freezing shadow zones, failing harvests, and shredded orbital infrastructure. Altering one massive variable in a planet's composition cascades through the entire ecosystem, forcing every living thing to adapt to a world where the sun itself is blocked by millions of tons of rock. Looking up at an empty blue sky suddenly feels like a luxury. Our quiet, ringless orbit is exactly what keeps our climate stable and our satellites safe. Knowing the environmental chaos and the technological isolation it would create, would you still choose to live on a ringed Earth? Let us know your decision down in the comments, and be sure to subscribe to Infinite Why for more science-based what-if adventures.